Okay, so in the previous video, we added mass and elasticity to our balls. So in this video, let's add the walls functionality. So we could have bounds across or around the perimeter of the canvas. So before starting, let's just remove a couple of things. Let's remove the console.log so the console doesn't get a bit messy. I believe there's another one somewhere here. And let's just create a new wall class. Wall and then the constructor. And the wall, it's going to take a couple of properties. One is going to be the start, which is a vector. Then it's going to be the end, which is also going to be a vector. Also an elasticity, which we will leave at 1 for now. And then finally a color, which will be black as a default. Now let's just set these values onto the wall. Alright, and now let's make a method to draw the wall. And this is going to need the canvas, so let's import it. So canvas.context.beginPath. Canvas.context.moveTo. And this is going to be the start position. And let's just not forget to convert it to a canvas y value. So canvas.toCanvasY. Let's also have a line to, which draws the line to the end coordinates. Let's also have a stroke style. This dot color. Oops. This dot color. And finally, let's draw it. We also need the unit vector going from the start to the end of the wall. So let's just do unit from start to end of wall. And we return this.start.subtract this.end.unit as so. Now let's actually draw this wall into the context. So let's call it wall equals new wall. And we forgot to export it, of course. Export default wall. Now I could use it over here. Start will be a new vector. And it will start at the center of the canvas. So canvas.element.client width divided by 2. And then canvas.elements.client height divided by 2. And it will end 300 pixels to the right. The color will leave it as black. So now let's just draw the wall. Draw. And there you go, you can see the wall. There's no collisions, but we'll do that right now. So to implement collisions, we're going to be going to the ball class, and we're going to be defining a couple new methods. So the first method is going to be closest point to wall, and it's going to take a wall as a parameter. And there's 3 situations to account for. So if ball is closer to start of wall, case 2, if the ball is closer to the end of the wall, and case 3, if the ball is closer to path of wall. So in case 1, what we're going to do is we're going to get the vector that points from the ball to the wall's start coordinate, which is wall.start, wall.start.subtract this dot position. Also, we're going to do something similar to the end. So over here we'll put end as well as here. And these are essentially vectors that from the ball to the start or end of the wall. And so we could draw this dot draw. We can set it as this dot position dot x as the ball's x and y positions. And we could do the same for this. And so if we actually call it, so ball1 dot closest point to wall with the wall as the parameter, we're going to see that two vectors are created, one pointing to the start, which is over here, and to the end of the ball. And we can use these to determine whether the ball is closer to the path, the start, or the end. So if it's closer to the start, then the projection of this vector onto the wall vector is going to be 0. So over here, the projection onto this, it's 0. Same goes with the end. And we can do this by having an if statement that checks whether or not the projection of the ball-to-wall start vector is less than 0. So wall.unit, because we want the direction, dot dot, so we get the dot product, ball-to-wall start. Now that's the projection. And now if this is less than 0, that means it's closer. So return wall.start, because we want to return the point. We're not returning a vector. Then we could do the same over here by simply copy pasting, putting this to end. However, this also needs to be 0 now. And then we do this, and we also do this. And so now you should see that whichever one is closer, it's going to draw the vector. And if it's not closer to any of them, it's not going to draw the vector right now because we haven't defined it. And if we go over here, it's going to draw the vector as well. So that's essentially the functionality that we have right now. And now let's implement when it is closer to the path. So first we're going to define a closest distance, which is essentially closest distance the ball has on this. So it's going to be here to here in this case. So closest distance equals wall.unit dot ball to wall start. And we're just going to use the start because it's a bit more manageable. Because this one, then we're going to have to switch the signs and all that stuff, which kind of gets a bit confusing. Then we get the vector of this. Wall.unit dot multiply closest distance. And so if none of these are the case, then we just return wall.start.subtract closest distance vector. And then closest point is simply wall.start.subtract closest distance vector. So now you could return this closest point. And if we'd like to draw it, what we could do is this dot position dot subtract closest point. And then we could draw it by doing this dot closest point vector dot draw this dot position dot x, this dot position dot y. And I need to switch these two, so closest point dot subtract this dot position. And now it should work, so there you go. You can see that it correctly determines the closest point to the wall at all times. However, we don't really need these two at the moment, so I'll just cut them and paste them over here for now. And we'll just return the closest point. So this one actually, we'll just return it like this. now let's make a new method called isPenetratingWall. And it essentially works the same way as a ball, except const ball to closest point is equal to this dot closest point to wall dot subtract this dot position. So it's essentially the same thing as this, but in vector form. We essentially get the same thing. Let's remove these as well. And all we have to do is return whether or not ball to closest point dot magnitude is less than or equal to this dot radius. And this checks whether or not it's penetrating. So now if we check, equals ball1 dot is penetrating wall, and we console.log it, you can see it is penetrating, and now when we move it away it's not, so it works. Now let's resolve the penetration. So resolve wall penetration. So the penetration vector is equal to this dot position dot subtract this dot closest point to wall. So this is essentially just the vector representing the distance between the ball and the closest point. And then we move the ball by adding the difference of the radius of the ball and the penetrating vector to its position. So this dot add, this dot position dot add penetration vector dot units on the same direction dot multiply this dot radius minus penetration vector dot magnitude. And now if it is penetrating wall, so if is penetrating wall, then ball1 dot resolve wall penetration wall. And let's just make this a bit more clear as well. Now I could test. So there you go, it works. It doesn't have the collision functionality, but you can see that I can no longer move the ball across the wall. And so finally, let's resolve the collision. So resolve wall collision. Let's get the normal, the unit normal of the ball to the closest point of the wall. So this dot position dot subtract this dot closest point to wall. Essentially what we did over there. Then we get the separating velocity. I forgot to add an L. Separating velocity, which is this dot velocity dot the normal, and the new separating velocity, which is negative separating velocity times this dot elasticity, or this is for the ball, right? So we could do the same thing as we did before, so the minimum, so this dot elasticity, and then wall dot elasticity, so whichever is smaller. And then we get the difference, so separating velocity difference equals new separating velocity minus separating velocity. And so finally we add the velocity that's in accordance with the ball moving towards the wall. There you go. And so now if we implement it, ball1 dot resolve wall collision wall, it should be working. There you go, see, the bounce happens, and then if we go onto the wall and put the elasticity as 0, we can see that the bounce, it doesn't bounce anymore. So there you go. So now we have walls, and finally let's just add the bounds. So to do so, let's create a bounds array, and also let's create an edges array, which is going to have the vectors of the edges of the canvas. So new vector 0, 0. New vector 0 canvas.element.client height. Over here, client width. And then we copy this. And so what we could do is for let's I equals 0, I must be less than or equal to 4 I plus plus. We can create the bounds for the canvas. And let's just have a comment here, create canvas bounds. So the start will be edges, and then what we could do is I, and then over here we could put the end as I plus 1 in brackets, remainder, edges dot length minus 1, or actually no, like that. And we push the bound into the bounds array. And we're still not done yet. Now we have to, for every ball, we have to loop over it. So what I'm gonna do is, we have ball 1 and ball 2, right? I'm gonna create a balls array with ball 1, ball 2. And then I'm going to do balls dot for each. And then I'm going to do again balls dot for each, ball 2 this time. And I believe I also need to add an index. So this loops through every ball for every single ball, right? So if I equals j, then return. So this is if it's looping with the same ball. It's looping over the same ball, return. Otherwise, we check if it's penetrating each other. So is penetrating ball, there you go. And then we do the same for wall. So let's just comment this. And then we check if penetrating any walls. So walls dot, or actually, what we could do is we can have a separate and in this case we only have the bounds, but what we'll do is we'll do const walls equals bounds. So the bounds are also part of the walls, and then what we do is walls dot for each wall, and then I copy paste it there. We also forgot to draw every ball, so let's just do that right now. So over here, we also have to add wall 1 to the walls array. We also have to draw every wall as well, so let's just do that before we draw the balls. So actually what we'll do here is we'll do render balls, and then we'll do render walls. Walls dot for each wall, and then I think we could just copy paste this. There you go. So now it should work. So if we add any other balls, I think it should work as well. And yeah, you could see that the bounds also worked. What I added previously, it works. Let me just edit this so that the elasticity is 1, so that now it can bounce off the other walls. There you go. Now we kind of have like a playground here, you can see. And that's essentially it. There's your engine for you right there. Now you could do whatever you want. You could make your own maze. You could create your own little games with it. I'm probably going to add other features in the future. I'm not exactly sure when, but I'll definitely make a video when I implement it. I want to focus on other things at the moment, and then the future, and then maybe I could add boxes and boxes that rotate and other stuff like that. And later on I could add maybe boxes, and whenever they collide they could rotate due to the torque imposed onto them, as well as other stuff. I'm not exactly sure when, because that's a bit complicated to implement. And this engine, although it's pretty fun to play with, it's by no means perfect. There's definitely better and more efficient ways to handle interactions like this. It's just it's the most simplest way to explain to other people without, you know, a great, without a, without like a without a really extensive knowledge in programming and other stuff in general. So that's kind of why I took this approach. But yeah, I guess that's it for the tutorial playlist as of now, and I'll probably see you soon. So yeah, see ya.